In this video, we're going to talk about inheritance within Kotlin. Inheritance in Kotlin is pretty similar to other programming languages, but if this is your first time learning about it, you can think of inheritance as basically the process of different classes within your code inheriting attributes from a parent class. So think about when you inherit your genetics from your biological predecessors. It's the same concept with code, where you can inherit from some sort of base functionality in some child classes. So you get this hierarchy of relationships within your classes, which can enable a lot of code commonality and also can result in writing less code if you have to share some common functionality among your classes. Without further ado, let's get into it. So to start, let's make a class called A. So in this class, a few things are happening. The first thing is that A is implicitly inheriting from something called any. So what I just had before and what I have now are semantically equivalent code. If you come from a Java background, this may be familiar, where any is the equivalent of object within Java, because any is the common superclass of all classes within Kotlin, just like object is for Java. The difference between object and any is that object has multiple different methods within it, whereas any only has three: toString, hashcode, and equals. The equals method verifies equality of an object. The hashcode method generates a unique code per object, and the toString method is basically a way that you can convert an object into a string. If I open the any class, you'll notice a few things right off the bat. First of all, we have the public visibility modifier here, and then we have the open modifier. The open modifier might be new, and basically the open modifier means that this class can now be extended. By default in Kotlin, all classes cannot be extended unless you explicitly indicate that they are open to extension. That's a pretty big shift from other languages that default to allowing inheritance unless you explicitly prevent it. In this case, in Kotlin, you explicitly have to enable inheritance. If you ask me, I think it's better to have to enable inheritance rather than to explicitly disable it, because a lot of people will try to misuse your code with inheritance, but that's just my personal preference. And then you'll also notice the public visibility modifier here. So inheritance applies to 3 of the 4 visibility modifiers within Kotlin. The 4, as a reminder, are private, protected, public, and internal. And the only one of those 4 that inheritance does not apply to is private. Therefore, if I have public, protected, or internal, I can inherit from all of those different members within my class, or if I have a property that's any of those, I can inherit from it. Now that we've talked a little bit about any, let's make our own superclass. So we're going to say class A is going to have a function called hello, which is just going to say in A. Now we want to make class B inherit from A, so we're going to use a similar syntax like we did last time, except now you'll notice that we have a warning here. And that is because we didn't declare A as open. So now that A is open, B can inherit from A. So to review what this syntax means here, B is essentially extending A right here. And then these parentheses are required when you have a class type, because this is calling the primary constructor within the A class, which is not available because it's implied. If I were to remove that, then Kotlin doesn't know what to do with that because it thinks that A is an interface. So since A is a class, we need to put those parentheses there. Okay, now if I make a value B, like so, I can do b.hello, and we'll see that I call the A version of hello, even though I don't have anything declared in B, because I was able to inherit the methods and the properties from A. Likewise, let's say that I've got property hello there. I can come down here and I can say b.prop. And I could print this out as well. And we see that it does say hello there. Just to demonstrate that the visibility modifiers work as expected, if I change this over to private, we now get a compilation error because the derived class B cannot see our property because it is now declared private. Now if I declare it protected, for example, we still get an error, but it's a different one this time. Cannot access prop because it is protected. So B does have the property available to it, but we just can't see it. Just to prove that, let's create hello2. And then in here, let's do prop. And we can see that this does compile b.hello2. And we do get the property value as expected from class A. Now that we've gotten into the concepts of inheritance a little bit, the next logical thing is polymorphism, which gets into some of the process where you can change derived class behavior. So for example, let's say that I don't like this implementation of hello, and I want to override it. Well, to do that in Kotlin, there are a few things that you need to do. The first thing is that in the derived class, you want to indicate that you have an override here. And the compiler is telling you, hey, I can't override that. And the reason is because just like with class declarations, you have to declare them as open, which allows them to be overridden. So now let's say I want to call println like this. And I want to call b.hello. We are now in B's implementation rather than A's. This does also apply to properties. So let's say I've got a val property called hello there. If I want to override that, I can say hello you. Except you'll see the same error. We have to indicate override and we have to indicate open here. So now that this compiles again. So if I were to get the property like so, and print it out for B, I get hello you, which is how it's declared within the B class, not within the A class. And again, the default visibility modifier in Kotlin is public, which is why all of this works when I'm not including visibility modifiers within the code. An important thing to think about when you're overriding a property is whether it needs to be a var or a val. So when my superclass has a val type, you can think of that as it has a getter but not a setter because it is read only. If I want my derived class to have a getter only, then yeah, that makes sense. If I want it to have a getter and a setter, then that is okay because the derived class may need to mutate the property, whereas the base class may not need to. However, let's say that I want the derived class to have a read-only version and the base class has a read-write version. That is not allowed because effectively what you're doing is in the base class, you have a getter and a setter because it's a var. And then in the derived class, if you have a val, then you effectively only have a getter. So you're removing functionality by removing the ability to have a setter. That is not something that the language allows you to do. You can always go from a val to a var within an inheritance relationship, but you cannot go from a var to a val. Let's say I remove the properties and I just go back to my hello method. And then now I want to have a class C, which inherits from B. So first, I have to declare B as open. Override modifier implies open. So we'll see what I mean here. So I could just do this. And now I could define in C. But let's say in B, I want to prevent that from happening. I want B to be the final place where I can extend the functionality of this hello method, and I want to stop it right there. I can do that with the final keyword. And now I know if I had a complicated inheritance hierarchy that this is the lowest subclass that can have an implementation of the hello method. And we get our error here. So now let's talk about how we can call the superclass from the subclass. So let's say instead of this, I want to also call the superclass implementation. I could do that. And that is effectively going to call the superclass implementation of hello and print in A, and then we're going to print in B. And there we have it. We call the superclass implementation, and then we have the subclass implementation here. So there are other ways that you can use the super keyword aside from just invocation of, let's say, a superclass method. Another main use case is when you need to call the constructor of the superclass. So let's say, for example, that we've got a color string here. Now what we would need to do is we would need to initialize the A constructor within here. So let's say that the color of A is black. This would compile because when B gets constructed, there's a primary constructor that automatically is going to call the superclass constructor, which then comes up to here. So another thing to think about is when you are creating an instance of B and you have init blocks and secondary constructors and all those sorts of things, the first thing that happens before any of that is done is a call to the superclass constructor, in this case A. That's an important thing in the order of initialization of classes to think about. Let's say though that B has a secondary constructor and it takes a size which is an integer. Now what I need to do is I need to explicitly call the superclass constructor A, like so. And then I don't call it here within the primary constructor. This is an alternative way to do the same thing when you have secondary constructors. If I had a different secondary constructor, I have to do this for every single one of them. If I didn't, then I would be having an error like this. Otherwise, what I could also do is I could say this one, and this would work because the secondary constructor of B here is calling the other secondary constructor, which is then calling the super constructor. So as long as there's a way that the derived class always has a method to call the superclass implementation before it does anything over here with its own initialization, then you're good to go. The last caveat of inheritance I want to talk about is when you have two superclasses that have implementations of the same method and then how you disambiguate that within your subclass. That was a lot of words. Let me show an example. Let's make an open class A with a method called hello, and it will print in A. And then let's make an interface B that will have a method called hello as well. And with an interface, I don't have to specify an implementation. So let's start here. Now I want to make a class C that extends A and implements B. This is perfectly legal because what I'm doing is I'm implementing the B interface by providing the implementation that A provides for an equivalent method hello here. So if I create an instance of C and I call c.hello, and we'll see here that it does call the A variant. Cool. Now the problem is Kotlin interfaces do provide a method for default implementations within an interface, just like Java introduced in Java 8. So now if I do this, Kotlin's like, okay, whoa, I don't know which version of hello you want me to use, A or B. This is referred to as the diamond problem in a lot of different programming languages. And IntelliJ is telling me that I must override it. Interesting. So what Kotlin is telling me to do is that I need to override this. But it gets fun because I need to use the override keyword, and the override keyword gets mad because I didn't have the open keyword used on the hello method within the A class. You'll note that I don't need to declare open on hello within the B interface because open is implied when you use interfaces. So now what I need to do is I need to determine how do I want to use hello. Let's say I want to use one of the superclass implementations. Well, the syntax to do that is a little odd. You use the angle brackets like this and you indicate the superclass implementation you want to talk to. So something like that. Let's say I want to call A and B. I would do so like this. And as we can see, we get the A implementation and the B implementation. Just one other thing I want to demonstrate really quickly is that like Java and Kotlin, you can't extend multiple classes. So if I change this into a class and I mark it as open, and now I need to declare B as open, Now I need to construct B, but I can't do that because B and A are now two different classes. I can extend one class, I can implement many interfaces. So this concept is similar to Java in that you can extend one class and implement many interfaces, but it's different from something like C++ where you just have straight up multiple inheritance. You can extend as many classes as you want. And that was an overview of inheritance within Kotlin. Hopefully you found this video helpful. If you did, please do smash that like button. I'd really appreciate it. Thank you for watching. I hope you have a good rest of your day, and I hope to see you next time. Take care.